Hello everyone. In this video I am going to discuss the concept of radian. Till now I had represented all the angles in terms of like 60 degree, 90 degree, 100 degree like this. So right now in higher classes we have to represent the angle in terms of another unit, which is radian. So what is this radian? So suppose I have one circle and the radius of the circle is r units. So radius of the circle is r units. So in this circle, if I will get, as the radius of the circle is 1 unit, if I will get an arc in this circle, if I will get an arc whose length is also r units. So radius of the circle is r units, an arc, the length of that arc is also r units, then this angle is known as 1 radian. So generally we represent 1 radian like this, multiple C. So this radian is also another termed as circular measure of angle. So again I can repeat this, that this is a circle of radius r units, radius of the circle is r units, that angle subtended by an arc of length r units, arc of length r units, the angle subtended by that arc in the center, that angle is 1 radian. We represented it by like this. Very famous formula, that is S equals to r theta. If I will just discuss that what is this S equals to r theta. Suppose we have one circle like this, and so couple of arc if I will draw over there. First one minute. So if I from the center, if this is the first line, this is my second line. 1 minute. If this is my second line is over here, and my third line is over there. This is the center of the circle, and this if I will join. So first one, if this is OL, this is N, this is N. So what we are imagining that this arc length LM subtends angle LOM in the center, okay, and this length of arc LN, this length LN is equals to OL, that is the radius of the circle. So what will be this angle? This angle will be 1 radian, we all already know, okay. We know that ratio of two arc in a circle is equals to a ratio of angles subtended in the center by the two arc, ratio of angles subtended in the center by those two arc. So from this diagram can we write that ratio of two arc, that is arc LM divided by arc LN. Arc LM subtends the angle LOM, and arc LN subtends the angle LOM, right? So now what is arc LN? The length of arc LN is radius OL, right? So if I substitute by radius OL, arc LM divided by simple one r, if I divide by r only, so angle LOM divided by, what is angle LON? We know angle LON is 1 radian, right? So angle LON is 1 radian, right? So can we write that angle LOM is equals to arc LM into 1 radian, arc LM into 1 radian divided by r, right? So if I will take the circular measure of angle LOM, so circular measure of angle LOM, if I will take that side, so circular measure of angle LOM, that will be equals to, if I'll take that as theta, so circular measure of angle LOM is equals to theta if I will take. So can we write that from there, that theta equals to, if arc LM, the length of arc LM I am taking over there as is, so theta equals to S divided by R. So from there we will get S equals to R theta, where S is the length of the arc, R is the radius of this circle, and theta is the circular measure of the angle. So theta, you have to mention it, theta is circular measure of the angle subtended by arc of length S in the circle of radius R units, right? So that time we can write S equals to R theta. Many times we are going to use this. First I am going to use this S equals to R theta. So as S equals to R theta, already we had proved. So can we write that R equals to S divided by theta? Correct? So R is constant for a particular circle, right? So can we write that R is constant? So any time the length of the R divided by this angle is always be a constant. So again, if I will try to draw one more circle over there, so from this circle I am going to prove something. So first, when this R is rotating this much of angle in degree, so that time it's covering 360 degree. And what is the length of the arc that time? That is the perimeter of the circle, that is 2 pi r. So 2 pi r, if the length, this S is 2 pi r, then the theta is 360 degree, right? And from the concept of radian, I know if this is r, so this angle will be 1 radian. So if I will take the S as r, then the theta will be 1 radian. So from there, if I'll cancel this and cancel this, so I will get that pi radian equals to 180 degree. Many times you will get confused in this, that pi radian equals to 180 degree. So how to use this? Suppose you need to calculate 60 degree. So 60 degree will be equals to pi radian divided by 3. Right? So many times you are going to use it as pi divided by 3 also. Pi by 3, if pi by 3 is angle, then pi stands as radian. And if pi by 3 is value of any other thing, value of any trigonometry ratio, inverse trigo, I am going to discuss this thing. So that time I am going to pi as 22 by 7. Don't get confused. If pi by 3 is angle, then pi is this radian, that is 180 degree. Otherwise, if this is the value of any other thing, then pi will be 22 by 7. So that's it for now. In my next video, I am going to discuss a couple of theory part of the higher class trigo. Stay tuned. Thank you.